Hi, this is Dick Berry. This is my light control project. I'm using a 46K22 processor so I can expand. So I had the expanded memory in both RAM and flash because the graphic stuff really does take a good bit of resources. So I went from the 45K22 to the 46, and so far I've used about half of it. All right, you'll see the target board is going to be a ready for pick board. The graphics display is what they sell on Micro, the ones that come off the shelf, like with your version 7. I bought a interface board for the touch panel, and we will be adding at a later date on, this is the head end side, and it transmits RF Bluetooth to the receiver, and there's the Bluetooth device, which I bought on eBay just because they were dirt cheap. All right. Well, we'll be adding the Smart MP3 board, and I chose that board because the SD card and the audio output are all on the same board using the same SPI bus. This is the Speak Up board, which I'll be using for voice recognition. The voice recognition isn't done yet. I started with just plain old touch panel control of the other side. So that's the head end hardware, and now we'll go over and we'll look at the receiver. All right, this is the receiver. The processor is a 16LF 1825, which is a 14-pin chip. On the right, you'll see 4 current sensors, so when I turn the lights on, I can report back what the current draw is, and we know that they've actually gotten lit. There's 4 transistors for driving the lights, and there's also 4 diodes. These are the light panels I'll be using inside my camper. The diodes are so this switch can go into manual mode, and what that switch does is turns off the power to the electronics and then grounds the inputs of those diodes so the lights can be controlled with their normal switch. So I'm switching the low side of the lights. This is the Bluetooth receiver. The Bluetooth stuff is the HC05, so they can be transmits or receivers. This won't change when we do voice recognition, and I will build this board myself because I need it to be pretty darn small and to be not very obvious when it's inside the camper. All right, for software, I'm using Micro Basic Pro and developing it on Easy for Pick version 7. Okay, I'm going to go through a little bit of the software now. When it starts up, it has a splash screen, and the only reason I have a splash screen is because I needed to do some software on the initial screen, which I'll show you in a minute, in order to display icons for the lights being on and off. So I made this little graphic of a pop-up trailer and put that on the splash screen. It gives you a good place to put the copyright too. You see the copyright is in the wheel of the pop-up. Anyway, then it has one huge button. The whole screen is a button, and it's invisible. All it does is it goes to the next screen, which is really the meat of it. This is what controls the individual lights. I have a table light, a hall light, a sink light, and a porch light in my pop-up, so this controls 4 lights. You see the little light bulb icons underneath the labels. Right now they're indicating that the lights are off, and if I turn the light on, you can see that the icon changes to indicate that the light's on, and sure enough, over there the light has become on. Those little panels actually put out a good bit of light. So, and then, oh, a little jerky around here, sorry. So we have some menu functions. This is where it'll live because this is where you can actually control the individual lights. And in the menus, I have all lights on, where you can turn on all lights and all lights off. A volume control, which I'll show you in a minute, and calibrate, which is coming up. I'll show you how you know how to calibrate the touch panel. If I do a check in the internal E squared prom, and if it's never been calibrated, I force a calibrate, but we don't go through that unless it's never been calibrated. And so on the menu screen here, you get an option to calibrate the touch panel if it's not actually dealing with it properly. So I've got a volume control because we do have speak recognition, and with the smart MP3 board, there'll be responses to those speech recognitions, and it is just a progress bar that controls the electronic volume. Sorry, I touched the wrong button. It controls the electronic volume on the smart MP3 board. And I ripped off the logo from Spinal Tap. If you notice, it goes to 11, and that was a big deal in the Spinal Tap movie about going to 11 on their amplifier. So we did that for just a little bit of fun there. Anyway, that Spinal Tap logo, I used the microelectronica software to build that logo, and it's a partial display. So I used the GLCD partial display routine to put that up. So you won't see that logo in the visual GLCD software. It's put up by my software. So now we get to more, and you can reset the receiver. So if these things get out of sync, then you can reset the receiver and it'll go back to the initial state. It'll recalibrate the current sensors and turn off all the lights. So that's just a convenience in case it gets out of sync. But we do have the status, and the status lights are the table light, the hall light, the sink light, and the porch light. So that then is all I have right now. There will of course be a few more buttons, but not many, because we're pretty much at the end of it. I'll show you if I turn all the lights on. It's pretty darn bright over there with all the lights on, because they're right next to one another. But at that point, then you go back, and all the little light icons are indicating on. So it's keeping track of all that kind of nonsense. And that's pretty much where we are. I'll move on to the status displays now. Now, on the display screen, we say which light it is, table light. Then we have the current data, which is, like I said, the 32 samplings of the A to D converter from the current sensor, which is a 5 amp sensor. So at these low currents, it's not a big difference. So I sample it 32 times. The calibration data, which is what I do when it initially starts up, and that's 32 samplings that doesn't change unless you send a reset. Then I have the difference, which is a low number if the light is off and a high number if the light's on. And the ADC results is the analog to digital converter results flags. And it'll say in the low order nibble if a light is on or off. And of course the light port is what the receiver over there is actually outputting to the port. And we see this light is on because we got a count of 231 difference, and I set the threshold at 100. So if the difference between the cal data and the current data is over 100, then the light is on, or supposed to be on. And of course evidence is looking up at the light, which is again over there and on. Okay, now let me go back, and I think that pretty much covers what I've got right now. And this ends up to be about 32K of memory. So Anyway, that's where I am right now. The software is moving along nicely. The visual GLCD has really been very helpful. It has some idiosyncrasies. You have to be very careful where you put your code, because it'll overwrite it and just erase it. So you know, you got to learn your way around it. The documentation is as thorough as I would have liked, but you know, after working with it for very few days, it actually comes out to be not that hard. Anyway, that'll be the extent of the video, and I'll download the sources and the schematic, and of course the ready for pick. You already have a schematic on. I do have to change the IOs. Right now, the standard IOs are being done. Port B is the control for the display, and port D over here is the data, but I have to change that, and I'll be putting the data on port B, and the controls are on, I think, port D, but it's in the same configuration as it was over here on this side over here. And actually the port chart is in the documentation as well, so you'll be able to see where I've rearranged ports, and I did that so I would have both our USARTs available, because the speech recognition module, I'm going to do on a UART, and it'll be sending it out. And this, of course, has to be on an SPI. So, and right now, the only thing I've got that has to be 5 volts is the display, and it must be 5 volts. But that isn't presenting a problem, because the Ready for Pick board has both voltages available. Okay, this will be on the YouTube, and I'll upload a link with it with the package. Thanks for watching.